Good evening dear students, welcome to GTQ, that is get through question practice questions we are going to do, right. In this we are going to start with the electromagnetic theory. We will solve few questions. I will give some time for you to solve. आप पहले उसको solve करोगे, then we will verify with the answers, right. So these are the basically few questions that we are going to practice within a limited period of time. Okay, so let's start with the first question. Question number 1, if electric field E is time and space dependent electric field vector, mu is permeability of the medium, epsilon is permittivity of the medium and sigma is the conductivity of the medium, then for charge free medium the electromagnetic wave equation is given by. This is basically what will be the answer. So here it is saying that it is a charge free medium, isn't it? Okay, so charge free medium means what? Charge free means rho v should be equal to 0. Okay, so if rho v is equal to 0, it means that del dot d should be equal to rho v and this should be equal to 0, right. And if del dot d is equal to 0, then what will happen to del dot e? It will be also becoming 0, right. That is the meaning of charge free medium, correct. Okay, now here they are asking the what will be the equation. Now we have Maxwell's equation. What are those equations? First equation we know that del cross E is equal to minus of del B upon del T, isn't it? Correct. So this is equal to minus of mu times del H upon del T, is it? So let us say this is equation number 1, correct. Second equation we have del cross H. So what is your del cross H? This is equal to sigma, or you can see that J plus del d upon del t, isn't it? Because the options are given in terms of time varying, so we will go for the instantaneous form. So J is equal to sigma E plus epsilon del E upon del t, is it? So this is equation number 2, correct. Okay, next we can apply, right. So if I do curl of 1 on both sides, so del cross E, this is equal to minus of mu times del upon del t del cross H. Can I write it like this? Right. So I have done the curl on both sides. So del cross E, this will become del cross H, right. So what is del cross E? This is nothing but your del dot E minus of del square E. This is equal to minus of del upon del t. What is your del cross H? So this is your sigma E plus epsilon del E upon del t, isn't it? Correct. So this will be the value. Now you can see clearly here you can see that del dot E is equal to 0, right. So if del dot E is equal to 0, it means that here this will become 0, right. So this negative sign and negative sign will get cancelled. So what is the value we are going to get? Del square E is equal to mu f into sigma del E upon del t plus mu into epsilon del square E upon del t square, isn't it? So let us see which option is matching, correct. So del square E, so del square E in the LHS. Okay, so if I take towards the left side, so what is the value we are going to get? So if I take towards the left side, I am going to get the value as del square E minus mu sigma del E upon del t minus of mu epsilon del square E upon del t square is equal to 0. So this will be the final value that we are going to get, right. So let us see which one is matching. Option A, del square E minus mu sigma del E upon del t minus mu epsilon del square E upon del t square equal to 0. So option A is the correct answer, is it? Okay, so that is the answer for the question number 1, fine. Next let us go to the second question, question number 2. I hope the solution is clear to everyone. So you can write your comment or write your answer in the chat box. Fine, okay. Next question number 2, try this one. Question number 2. Yes, A is the correct answer. Question number 2. Yes, A is the correct answer. Question number 2. A transmission line has a characteristic impedance of 100 ohm and line resistance of 0.5 ohm per meter. If the line is said to be distortionless, then its attenuation constant is what? Right. So how you are going to solve it? See, in this case, a transmission line has the characteristic impedance of 100 ohm. That means Z0 value, it is given as 100 ohm, isn't it? And the line resistance, that means R value, it is given as 0.5 ohm per meter. The line is distortionless. Line is said to be distortionless. Is it? Yes. Then they are asking what is the value of alpha. Correct? Okay. How to do 1699? इसमें mode of operation क्या होगा? That question is from, इसमें mode नहीं है, right? Because that is not from the rectangular waveguide. That is a simple waveguide, a simple wave equation. तो उसमें जब तक waveguide में आपको mode नहीं पूछा जाएगा, they are not asking in the previous question. They are asking what is the one student is asking what is the mode of operation. So this is the basically EM wave, right? So this is the general method we are using. It is not asking which mode. So we cannot tell that in which mode it is, because it is nothing is mentioned about the rectangular waveguide. तो हम नहीं बता पाएंगे. Correct? Okay. इसमें आ जाओ. अब इसमें कैसे solve करेंगे इसको देखो. Z0 ये this is equal to root under L by C, right? Okay. What is R? So distortionless. So they are asking the R is value is given, right? And what is alpha they are asking? What is alpha actually, right? So alpha is equal to root under RG. From here you are going to get, correct? Okay. This is similar as R times root C upon L. This is also fine. So for distortionless, this value. Now can I write it like this? So R upon Z0. Can I write it like this? हम इसको ऐसे भी लिख सकते हैं. Z0 है root under L by C, तो ये हो जाएगा upon Z0 में आ जाएगा. तो डायरेक्टली वी कैन डायरेक्टली सब्स्टिट्यूट दिस वैल्यू. R की वैल्यू कितनी दे रखी है? 0.5, राइट? और Z0 की वैल्यू हाउ मच? 100, राइट? सो दिस इज हाउ मच? 0.005 नेपर पर मीटर. So 0.005 नेपर per meter. Answer is A. Question number 2, answer is A. Yes, correct. Srinivas has given correct answer. Devesh Pandey, yes, correct. So this is the correct answer. Fine. Simple question. Next, question number 3. A lossless open circuited line with characteristic impedance of Z0 has input impedance as minus JZ0. The minimum length of the line is how much? So let us solve this question. Okay, so let us see what is the solution to this question. Question is saying a lossless open circuit line with characteristic impedance Z0 has. So that means we have an open circuit line. So let us say this is a transmission line, correct? मान लेते हैं हमारे पास एक transmission line है, and the characteristic impedance of this transmission line is Z0, and this is an open circuit at the end, right? Now here we have the input impedance Z open circuit, correct? This value it is given as minus of JZ0. The value of characteristic impedance is Z0 only, right? So what we can do here, we know that Z open circuit is formula is minus of JZ0 cot of beta L, is it? Now this is given as minus of JZ0. This is given in the question, right? This is given in the question that the input impedance is minus JZ0. So it means that cot beta L is equal to 1. It means that cot of beta L, this should be equal to 1. So if cot beta L is equal to 1, it means that tan beta L, it will be also equal to 1. It means that beta L, it is equal to pi by 4, right? It means that the length should be pi by 4 beta, is it? So this is equal to pi upon 4. Beta is how much? So this is lambda upon 2 pi, is it? So pi is gone. So what is the answer? It is your lambda by 8. So answer should be option A. Question number 3, answer is A. Yes. Fine. Okay, so that is a simple question. Lambda by 8 is a correct answer. Next, try this question. Question number 4. Question number 4. The electric field of a uniform plane wave is given by E is equal to 10 sin omega t minus pi z ax plus 10 cos omega t minus pi z ay. The polarization of the wave is. Now, in this question, they are asking which type of polarization we are going to get, right? And when we get the polarization, we will try also, because in the question, though even though it is not mentioned, in the question it is not mentioned that whether it is left circular or right circular, but we are going to find what will be the type of polarization also, left circular or right circular, left elliptical or right elliptical. So first of all, we are going to find what is the polarization nature, correct. Now, you can see that the wave is traveling in which direction? It is in the positive z direction, isn't it? The wave is traveling in positive z direction, so transverse plane will be z equal to 0 plane, right. So at z is equal to 0, right, at z is equal to 0, because we know that the polarization, the definition of the polarization is nothing but the electric field as a function of time. So that means the space quantity has to be put to be 0 value, right. So if I put z is equal to 0, so what is the value of electric field we are going to get? So electric field I am going to get 10 times sin omega t ax plus 10 times cos omega t ay, right. Now you can see that in this particular case, mod of ex naught and mod of ey naught both are same, isn't it? So both are 10, and you can see that there is a phase difference of how much? Phase difference of 90 degree, right. It means what? It means that it is your circularly polarized wave. Answer is clear. It is circular, but my question is, if it is circular, then can anybody tell me whether it is left circular or right circular, right? My question, even though it is not asked, but we are going to extend this question to that level. We are going to find whether it is a left circular or right circular. It is very simple to analyze the type of polarization. Amplitude same, phase difference of 90 degree, circular. It is satisfying the condition of circular polarization. My question to you is whether it is left circular or right circular. Let us see how many of you can answer it. How to do? It is 2-0. It is T20. Yeah, because TM00, TMM0, TM01 does not exist. Understood? How to do 1699? TM00, TMM0, TM01 does not exist. Okay. So whether it is LCP or RCP, how you will check? Now see, it is very simple to analyze. Put t equal to 0. See, let us see, at t is equal to 0, omega t will be 0, right. Then what is the value of E? E will become only 10 ay, isn't it? So omega t will be 0, this will become 0, this is only 10, okay, fine. If I put t is equal to t by 4, what is the value of omega t? It is your pi by 2, right. Then what is the value of E? It is your 10 ax, is it? So at t is equal to t by 4, omega t will become pi by 2, so 10, this will become 0, right. And what is the direction of the wave propagation? It is along the z axis, correct. So what I will do is, let us say this is the x axis, let us say this is the y axis, okay. Let us consider this is the x axis, let us consider this is the y axis, fine. So we are going to get the circular polarized wave, there is no doubt in this, it is a circularly polarized wave, right. Now what you have to do here, at t is equal to 0, it is 10 AY, that means this is your 10 at t is equal to 0, isn't it? Okay, fine. And at t is equal to t by 4, I am getting 10 AX. So this is your 10 at t is equal to t by 4, isn't it? So that means how the time is increasing, that means the wave is polarized, circular polarized, so it is in this direction, isn't it? So you can see that time is increasing in this direction, and this is your basically z axis, is it? Okay, so now tell me which type of polarization it is your. Now you can see that the wave is traveling along z direction because there is a minus sign, so the wave is propagating along z direction, right? And the wave is going like this, and it is coming in the forward direction towards you. So the wave is traveling along z axis, and the wave basically it is going in the clockwise direction. So which polarization? So obviously I have to use right hand or left hand. So you can see that if I put my thumb along the wave propagation direction, and this curling and the increment of the time both are matching, right? But if I use my right hand, if the wave is going in this direction, so my curling is in this direction, but the wave is going towards clockwise direction, right? So therefore if the wave is going like this, so this is your thumb and this is the direction of the wave, right? This is the direction of the wave and this is the polarization. So therefore I am using my left hand, so this will become LCP, left circular polarized wave. Got the point? Okay. So even though it is not asked, but in the gate examination you will get this similar question, whether left or right, right? If it was elliptical, then whether it was left elliptical or whether it was right elliptical, that is very much, you know, simple question. Or many time you can see that if you do the PYQ also, you will find this left circular, right circular, something like this. Correct? Got the point? Next. Clear everyone? Okay. Now next, question number 5. It is required to propagate 30 gigahertz signal in an air-filled rectangular waveguide A is greater than B in T01 mode in such a way that lambda naught upon lambda g is equal to 0.80. If the dimensions of the waveguide are A into B and A is greater than B, then the narrow wall dimension of the waveguide will be how much, right? So how you are going to solve this question? Okay. So let us solve. Now it is saying that it is required to propagate 30 gigahertz. So what are the data that has been given? Frequency of operation is how much? It is 30 gigahertz, isn't it? Okay. And it is your air-filled rectangular waveguide, correct? So this is your air-filled rectangular waveguide. Waveguide having A is greater than B, right? And it is in T01 mode propagation. So this is your mode of operation is T01 such that lambda naught upon lambda g, it is given as 0.80. If the dimension of the waveguide is given as of A into B and A is greater than B, it is already mentioned earlier, then the narrow wall dimension, that means what they are asking, A or B? They are asking B, narrow wall, right? So they are asking what is the value of B, is it? Right? They are asking the value of B. Okay, so answers are coming. So option, somebody is saying option B. Okay, let us do. Now lambda naught upon lambda g, right? We know that lambda g is basically a guide wavelength. This is given by the formula lambda naught upon root under 1 minus fc upon f whole square, isn't it? This is the formula, correct? So I can say that if I do root under 1 minus fc upon f whole square, this should be equal to lambda naught upon lambda g, isn't it? Correct? So from here I can say that 1 minus fc upon f whole square, this is equal to lambda naught upon lambda g whole square, isn't it? Okay. So from here I can say that fc upon f whole square is equal to 1 minus lambda naught upon lambda g whole square, right. So from here I will get fc upon f, this is equal to 1 minus lambda naught upon lambda g whole square root under, right. So what is the cutoff frequency? Cutoff frequency I am going to get f times 1 minus lambda naught upon lambda g whole square, right. Now they are asking it is working in T01 mode, and you can see that it is basically air filled, right. So it is air filled rectangular waveguide. So cutoff frequency, it will for T01 it will become C upon 2b, isn't it? C upon 2b, this is equal to frequency f root under 1 minus lambda naught upon lambda g whole square, correct. Or rather let us solve this first, because otherwise it will become a very long process. So frequency of operation is how much given? Frequency of operation 30 gigahertz, okay. So frequency of operation is 30 gigahertz, so 30 root under 1 minus lambda naught upon lambda g, is it? So lambda naught upon lambda g given, yes. So lambda naught upon lambda g is 0.80 whole square gigahertz, right. So what is the cutoff frequency? So this is 64, 1 minus 64, 0.36, 0.6, right. So this will become 18 gigahertz, right. So 0.6 into 30, so 18 gigahertz, okay. Cutoff frequency is 18 gigahertz. So what is cutoff frequency of T01? Because it is working T01 mode, so I can say that C upon 2b is equal to 18 gigahertz, right. So from here what is the value B? B is equal to C upon 2 into 18 into 10 to the power 9, right. C is the speed of light, so this is your 3 into, now option is in centimeter, so I will directly use 3 into 10 to the power 10 upon 36 into 10 to the power 9, right. So let us calculate this value. 3 to the power 10 divided by 36 to the power 9, 0.833 centimeter, 0.833 centimeter should be the answer, 0.833, yes, option A. So option A is the correct answer. Yeah, those who have given this answer 0.83, they are correct. Next, okay, next question. Try this. An optical fiber cable is shown with refractive indices as labeled. Incident light enters at an angle phi 1, right. So this is falling at an phi 1 in the air. If once the light totally reflects at upper N1 N2 interface, so you can see that it is perfectly reflecting, then the light remains confined to the guide, okay, fine. The maximum value of phi 1 for which the confinement occurs is how much? So they are basically asking what is the value of phi 1. Okay, let us see how many of you can answer this question. Try this. Okay. So basically this is nothing but your, there is a total internal reflection. So we know that sine of phi 1, right, this should be equal to root under n1 square minus n2 square, isn't it? So therefore sine of phi 1 n1 is your 1.50 whole square minus 1.20 whole square, right. So what is the value of sine of phi 1? Sine of phi 1, so this is 1.50 square minus 1.20 square, so this is coming to be 0.9, right, this is your 0.9. So what is the value of phi 1? So this is equal to sine inverse 64.16 degree approximately, right. So this should be the value. So this is question from optical fiber cable, and this is nothing but your numerical aperture, right. So answer is your 64.16 degree, is it? Clear everyone? Yes, Ashish Kumar, correct answer. Next, question number 7. A certain antenna with an efficiency of 98% has the maximum radiation intensity of 1.5 watt per steradian. The directivity if the radiated power is 0.5 watt will be how much dB, right. So let us see how many of you can do it. Okay. Now what is the, let us solve it. A certain antenna with an efficiency, so radiation efficiency is your 0.98, correct, has the maximum radiation intensity U max, maximum radiation intensity is 1.5 watt per steradian. The directivity if the radiated power, so power radiation is how much? Power radiation is a 0.5 watt. They are asking what is the directivity in dB, right. So directivity in dB. Now if we go by the definition, we know that the directive gain GD, it is equal to U theta comma phi upon U average, isn't it? This is the definition of directive gain in any theta phi direction, right. GD theta comma phi, correct. Now we know that this GD theta comma phi, this is equal to U theta comma phi, and U average is nothing but your P radiation upon 4 pi, right. So this can be written as 4 pi U theta comma phi upon P radiation. Now they are asking the directivity. So by the definition, directivity is nothing but your maximum value of GD, directive gain. So this will be how much? This is equal to 4 pi U max upon P radiation, is it? So here in the question already maximum radiation intensity is given, radiation is also given. So all the data are given. So here 0.98 is not applicable here because this is the efficiency, and based on this efficiency they have calculated these values, correct. So we are going to just put it value. So 4 pi, what is your U max? 1.5 upon how much is power radiated? 0.5. So let us calculate this value. 4 pi into 1.5 divided by 0.5, 37.7 approximately we can consider, 37.7. They are asking in dB. So D in dB will be how much? It is equal to 10 log 10, 37.7, right. So log 37.7 into 10, it is 15.76 dB. So this should be the answer. Yes, 15.76 is the correct answer. Clear? Next, question number 8. The cutoff frequency of a dielectric field rectangular waveguide for TM11 and TE30 modes are both equal to 15 GHz. If the dielectric has epsilon equal to 4 epsilon naught, then the dimension of the waveguide will be how much? Okay, so let us solve this. The cutoff frequency of a dielectric field rectangular waveguide for TM11 and TE30 modes are same, right? It is saying that cutoff frequency of TM11, it is same as cutoff frequency of TE30, and this value is given as 15 GHz. Right, so this is the value that has been given, right? Okay, if the dielectric has epsilon value, it is equal to 4 times of epsilon naught, then they are asking what is the value of A into B, is it? Fine. Now we know that cutoff frequency for T30, or you can see cutoff frequency formula, it is given as V upon 2 root under M upon A whole square plus N upon B whole square, right, where V is equal to C if it is air filled, and this will become C upon root under epsilon R if it is your lossless dielectric, isn't it? Fine. Okay, so here cutoff frequency of TE30 let us find, because we will get one dimension out of here. So this will become C upon 2 root under epsilon R. Here M will become 3, so it will become only 3 upon A, right. So M will become 3, N will become 0, so 3 upon A whole square will be 3 upon A. So this is nothing but your 3C upon 2A root under epsilon R. So we can directly, and this value, it is basically from here I can get the value of A, right. Okay, so from here what is the value of A we are going to get? So this is equal to 3C upon 2 times cutoff frequency of T30 into root under epsilon R. So this is equal to 3 into C means 3 into 10 to the power 8, or in centimeter if I directly find, so it is 10 to the power 10. 2 into cutoff frequency is given as 15 giga, so 15 into 10 to the power 9 into root under epsilon R. So epsilon R is equal to 2, right. So let us calculate this value, how much we are going to get. So this is your 9 to the power 10 divided by 60 to the power 9, 1.5 centimeter, right. So we are getting 1.5 centimeter. So 1.5 centimeter means either A or C, either A or C. Other part we have to calculate. Okay, so how you will calculate? So this has to be come from TM11, right. So now cutoff frequency of TM11, cutoff frequency of TM11, this will become C upon 2 root under epsilon R root under 1 upon A whole square plus 1 upon B whole square, right. So cutoff frequency, this is 15 gigahertz, right. Okay, fine. So from here I can say that cutoff frequency is 15 gigahertz. So 15 into 10 to the power 9 is equal to 3 into 10 to the power 10, because we are taking in centimeter, right. So this is 2 into 2 root under A value is 1 upon 1.5 whole square plus 1 upon B whole square, right. So let us calculate the value of B from here. So this is your 60 to the power 9, right, divided by 3 to the power 10. So this is 2 whole square minus 1 divided by 1.5 square, right. So 1 by B square we have got, so root of answer. So 1 divided by answer, it is coming 0.53, B is coming to be 0.53 centimeter, right. So A we have got and B we have got. So let us, okay, so 0.5, so obviously option C is the correct answer. So C will be the correct answer. Clear? Okay. Next. Question number 9. A wave propagating in a lossless dielectric has the components electric field and magnetic field is given. The wave is traveling at velocity 0.5 into speed of light. C is nothing but the speed of light. Then the relative permeability of the medium will be how much? Ashish Kumar, there is no hard and fast number of questions from the antenna. It can be any number. It can be 0, it can be 1, it can be 2, it can be 3. कुछ भी हो सकता है, ऐसा कुछ भी नहीं है कि एंटेना वाले पार्ट से इतने फिक्स्ड ही हैं कि आएंगे, ठीक है. So you have to prepare all the subject with all the chapters. Okay, now let us solve this question. Question number 9. A wave propagating in a lossless dielectric, right. This is a medium is what? Lossless. It is a lossless dielectric, right. Has the electric field component, correct. So electric field and magnetic field both are given. The wave is traveling with a velocity v is equal to 0.5 c, where c is nothing but the speed of light, but obvious it is the speed of light, correct. Then the relative permeability of the medium will be how much? They are asking what is the value of mu r. Is it? Got the question? Now how you will solve it? See, here you can see that I will write here. We know that eta, it is equal to mod of E upon mod of H, is it? E upon H. So mod of E will be how much? This is 500, and mod of H, this is how much? 1.1. So how much we are getting? 500 divided by 1.1, 5454, oh nice number, 454.54, correct. So 500 divided by 1.1. Now we know that eta is nothing but your root under mu upon epsilon also by definition. So this is nothing but your 120 pi root under mu r upon epsilon r. So now both the value will be same. So if I equal it, so I can say that from here 120 pi root under mu r upon epsilon r, it is equal to 454.54. So from here I will get the value of mu r upon epsilon r, right. So this is your 454.54 divided by 377 whole square. It is coming 1.4536, correct. So this is the value I am going to get mu r epsilon r ratio. Further, V is given, right. So further V, it is given as 0.5 C. What is V? V is equal to omega upon beta. This is equal to 0.5 C, isn't it? Okay. What is beta? Beta is equal to omega root under mu r into epsilon r, right. Omega by C, right. Omega by C root under mu r epsilon. This is equal to 0.5 C, correct. Okay. So from here I am seeing that omega omega is getting cancelled. So C upon root under mu r into epsilon r is equal to 0.5 C. So C and C is getting cancelled. So from here I will say that 1 upon root under mu r into epsilon r is equal to 1 by 0.5, which is equal to 2, right. One second, I have written wrong. So from here I can say that root under mu r into epsilon r is equal to 1 by 0.5, this is equal to 2, right. So what is the value of mu r into epsilon r? This is equal to 4, right. Now once we have got mu r and epsilon r product and its ratio, so directly we can use, so therefore I can say that if I multiply both, that is mu r into epsilon r multiplied by mu r upon epsilon r, so this will become 1.453 multiplied by 4. So here you can see that epsilon r and epsilon r is getting cancelled. So mu r will be how much? So 1.453 multiplied by 4, root of answer, it is coming 2.41, 2.41. So this should be the answer. So answer is 2.41. Okay, so which option? Option B. B is the correct answer. Yes. Got the point? I hope it is clear to everyone. Next. Try this. Question number 10. A 400 megahertz wave is propagating along an insulated copper wire. Assuming that skin depth of copper is very less than the wire radius, epsilon r is equal to 4 and sigma upon omega epsilon is equal to 10 minus 3 for insulation, then alpha of insulation upon alpha of copper will be how much into 10 to the power minus 8. Given conductivity of the copper as 5.8 into 10 to the power 7 mho per meter, right. So I will give you 1 minute, try to solve it. Let us see how many of you can solve this question. Read question carefully and then attempt. Okay, so let us solve this question now. See here, frequency of operation is given how much? It is given as 400 megahertz, right. Okay, propagating through an insulated copper wire, that means there is a copper wire which is basically insulated by some insulating material. Assuming that the skin depth is of the copper is very less than that of the wire radius, and epsilon r is equal to, so what are the data that has given for the insulator? For the insulators, what are the data that has been given? So for the insulator, so it has got relative permittivity as 4 and sigma upon omega epsilon as 10 to the power minus 3 for insulation. Then they are asking what is the ratio of alpha insulation of alpha copper, conductivity of copper has been given, right. Now this is NAT. So see here, let us find first alpha of insulation. First we will find alpha of insulator or insulation, and then we will find for the copper. Now see, we know that what, remember one thing, sigma upon omega epsilon plays a very important role to apply the formula when the medium is lossy, right. Now here sigma upon omega epsilon, if you remember, if it is less than 0.01, it is basically low loss or good dielectric, is it? If it is lying between 0.01 to 100, it is basically partially conducting, it is your partially conducting, right. And if it is greater than 100, right, then it is a good conductor, isn't it? Fine. Now in the question, if you look here, so here sigma upon omega epsilon in this particular question, sigma upon omega epsilon is 10 to the power minus 3, right. That means it is lying in which section? It is lying in this section, isn't it? It is lying in this section, isn't it? It will lie in this section, correct. So that means the sigma upon omega epsilon is lying for the good dielectric or low loss dielectric, right. So we know that, so therefore, so that was the catch, right. So therefore alpha for low loss, what is the formula? This is given by the formula sigma by 2 root under mu upon epsilon, isn't it? Sigma by 2 root under mu upon epsilon. Okay. So therefore this is your alpha of insulation, this is equal to sigma can be replaced with omega epsilon. Okay. Now sigma upon omega epsilon, here what it is given? Now here you can see that since sigma upon omega epsilon, it is given as 10 to the power minus 3, right. So therefore what is the value of sigma? It is equal to 10 to the power minus 3 into omega epsilon. So I can replace sigma with this value. So this is your 10 to the power minus 3 omega epsilon by 2 root under mu upon epsilon, right. Okay. So what is the value of alpha insulation? So alpha of insulation, it is equal to 10 to the power minus 3 into omega means 2 pi. What is the operating frequency? 400 megahertz. So 400 into 10 to the power 6 into epsilon naught, 8.85 into 10 to the power minus 12, and epsilon r value is given as 4 divided by 2, right. And okay, this can be further written like this also, 10 to the power minus 3 omega epsilon upon 2, right. So this can be further written as right. This can be written as 120 pi root under mu r upon epsilon. Can I write like this? So this mu upon epsilon, right, this mu upon epsilon can be written like this, isn't it? So this root under mu upon epsilon can be written as 120 pi mu r epsilon r. So therefore this value will be how much? So this is equal to 120 pi. Mu r is we will take as non-magnetic, right. So copper is a non-magnetic insulator, nothing is given about mu r, so we will take as a non-magnetic medium, and epsilon r. So this will become upon 2, isn't it? So root under epsilon r is equal to 4, so root will become 2, right. So you can see that this 2 and this 2 is getting cancelled, and this, or we can directly cancel this 2, 2, 4, right, we can directly cancel it. So, what is the value of alpha insulation we are going to get? So, let us calculate this alpha insulation now. So, alpha for insulation, it will be how much? So, this is 10 to the power minus 3 into 2 pi into 400 to the power 6 into 8.85 to the power minus 12 into 377. So, alpha insulation is coming to be 0.00838. So, we can approximately write 8.0084, right. Okay. So, this we have got for the alpha of insulation, is it fine? Next, next we have to find alpha for the copper, right. So, we have done for the alpha of insulation. Now, what will be for alpha of copper? So, it is very simple, alpha copper. So, copper is a good conductor. So, for good conductor, this is equal to pi f mu into sigma. That direct formula we can write. So, this is equal to root under pi, frequency is 400 megahertz. So, 400 mega means 400 into 10 to the power 6, mu will become mu naught. So, 4 pi into 10 to the power minus 6 into conductivity of copper is given 5.8 into 10 to the power 7, 5.8 into 10 to the power 7, right. So, let us calculate this alpha of copper. So, this is pi into 400 to the power 6 into 4 pi into 10 to the power minus 7 into 5.8 to the power 7. So, it is coming 3.03 into 10 to the power 5, correct. Now, in the question what they are asking? In the question they are asking alpha of insulation upon alpha of copper, right. So, therefore, alpha of insulation upon alpha of copper, this is equal to 0.0084 divided by 3.03 into 10 to the power 5. 0.084 divided by 3.03 to the power 5. So, it is coming to be 2.77 into 10 to the power minus 7, right. So, this is the value we are going to get, correct. Now, this which, okay, this is NAT. So, 10 to the power minus 8 they are asking, right. Fine. So, 0.0084 divided by 3.03 to the power 5. Oh, power is 8. 2.77 into 10 to the power minus 8. So, it is also in minus 8. Okay. So, what is the answer? So, therefore, answer is a 2.77. This should be the answer. So, this is NAT. So, answer is 2.77. Is it? Clear? So, here the catch was about this, how to find this alpha insulation, because most of the students will be comfortable in finding alpha of copper, because directly this copper is a good conductor. So, we can directly use the formula of good conductor. The catch was how to find the alpha of insulation. So, for the alpha insulation, this sigma upon omega epsilon range is given, right. Okay. So, from there I can we will use this concept, and from here only we can get the value of alpha of insulation, right. So, answer is 2.77, correct. Clear everyone? Shall we go to the next question? Yes. Next, in the free space region x less than 0, the electric field intensity is given. The region x greater than 0 is a dielectric for which epsilon r2 is equal to 2.5. The angle that the field in the dielectric makes with the x equal to 0 plane is how much degree? So this is the question from the boundary condition, right? You should know from which part of the chapter it is being asked. Okay. Good, answer is correct, that is very good. Okay, so let us solve this question. Now let us consider this is the interface, right? Let us consider this is the interface, right? And this interface is your x equal to 0. This is x equal to 0 is the interface. So this is your x less than 0, and let us say this is x greater than 0, right? So we have a normal a n cap. This is your a n cap. So this a n cap will be, but obviously it will be ax, right? Now what is the question? In the free space region, so x less than 0 is a free space, okay, fine. So let us consider this to be medium 1 and this is the free space. So epsilon 1 or epsilon r1, let us say it is equal to 1, and the electric field in this region, electric field E1 vector, this is E1 vector, right? So E1 vector in this medium x less than 1, sorry, x less than 0, it is given as thrice ax plus 5 ay minus thrice az cap volt per meter. The region x greater than 0 is dielectric for which epsilon r2 is equal to 2.5. So here let us say this is medium number 2, and for this epsilon r2 it is given as 2.5, right? The angle that the field in the dielectric makes with the x equal to 0 plane. So they are asking what is this value, alpha 2. If this is your, because it is asking the angle that this electric field is making with x equal to 0 plane. Correct, okay. Now, so how you will do it? Let us consider this angle is theta 1 and let us consider this angle is theta 2, correct, okay. Now here E1 vector is given. So from here what will be your E1 n vector? So E1 n vector will become E1 dot an in the direction of an cap, right? So E1 dot an, so here normal is nothing but your ax, so E1 dot ax in the direction of ax, so this is equal to thrice ax, right, okay. So what will be your E1t then? E1t vector will become E1 minus E1 n vector, so this is nothing but your 5 ay minus thrice times of az, right, okay. So here we have two components, one is tangential component, another will be your normal component, isn't it? So this is your E1 tangential and this is your E1 normal, isn't it? So E1 tangential, E1 normal, it is known. Now from figure tan of theta 1 is how much? It is equal to perpendicular upon base. So perpendicular upon base. So perpendicular is your mod of E1t and base 1 is your mod of E1n, isn't it? So theta 1, so this is perpendicular and this will be the base. So E1t, so this is equal to root under 5 square plus 3 square, and E1n it is equal to 3. So this is how much? 25 plus 9, 34. So root under 34 divided by 3, right. Now what I can do is, now I can apply law of refraction, right, I can apply. So therefore law of refraction Now here nothing is mentioned about the charge, surface charge, right. So surface charge density is not mentioned, so I will take 0 coulomb per meter square, right. So if not mentioned, we will take 0. So law of refraction says that tan of theta 2 divided by tan of theta 1, it is equal to epsilon 2 upon epsilon 1, correct. So therefore tan of theta 2, it is equal to epsilon 2 upon epsilon 1 into tan of theta 1, is it? So what is the value of tan of theta 2? So epsilon 2 is equal to 2.5 epsilon naught upon epsilon naught into tan theta 1 is your root under 34 divided by 3. So from here I will get the value of theta 2, right. So epsilon naught is getting cancelled. 2.5 into root of 34 divided by 3, right, shift of tan inverse 78.37 degree, but they are asking they are not asking theta 2, they are asking rather alpha 2. So what will be the value of alpha 2? So alpha 2, it will be your 90 minus theta 2, isn't it? So if I subtract, I am going to get 11.62 degree. So this should be the answer, 11.62 degree. So this is your NAT, so answer should be 11.62 degree, is it? Clear everyone? Okay, you are getting 11.64, there is no issue. Srinivas, no issue if you are getting 11.6, because this is NAT, so there will be range, and basically it all depends upon what is the approximation, how many decimal points or how you have approximated. So that is why it is you are getting 11.64, some may get 11.63, no problem in that, because there will be range, maybe they will give range from 11 to 12, something like this, right. So there is no issue. So answer is 11 point whatever you have got, that is correct. Next question, question number 12. So let us try this question. Question says that at a distance of 20 km from half wave dipole antenna in air, the maximum electric field strength is 5 volt per meter. The maximum magnetic field strength at 30 km distance from it will be how much milliampere per meter, right. So what is the question again? So 20 km from a half wave dipole, the electric field is given, right. So let me summarize the question here. It is saying that electric field at a distance r is equal to 20 km from a half wave dipole, it is your 5 volt per meter. They are asking what is the magnetic field at r is equal to 30 km will be how much, that is the question, right. That means it is a far field from the antenna, isn't it? So we know that, how you will do now? At far field we know that electric field is inversely proportional to r. So this concept has to be applied, right. So at far field electric field is inversely proportional to distance. So I can say that E dash upon E, it is equal to r dash upon r. So what is the value of E dash? E dash is equal to r upon r dash into E, right. So 30 km, okay. R is your, let us say it is 20 km, r dash is your 30 km, and electric field is how much? 5, right. So this is how much? 10 by 3, right. So that means at 30 km distance, what is the electric field? 10 by 3, right. So therefore what will be your H dash? H dash, it will become E dash upon eta, right. So E dash upon eta, now it is in the free space, right. It is clearly mentioned it is in the air, it is clearly mentioned it is in the air, right. So if it is in air, so I can say that this is 10 by 3 into 120 pi, right? So what is the value? So 10 divided by 3 into 377. So 1, 2, 3, 8.84 milliampere per meter. 1, 2, 3, 8.84. So it is coming to be 8.84 milliampere per meter. So this should be the answer. Is it? I hope everybody got this concept. Is it clear? Next, question number 13. A rectangular waveguide operates at 5 GHz in dominant mode if the groove velocity is given by 1.25 into 10 to the power 8 meter per second, then the largest dimension of the waveguide is how much? Assume the waveguide is filled with a dielectric material of epsilon is equal to 3.5 epsilon naught. Now how you will solve this question? So I will give you few seconds, try it. See, a rectangular waveguide operates. So what is the frequency of operation? It is your 5 GHz. Frequency of operation is 5 GHz in dominant mode. So dominant mode will be T10 mode. Dominant mode. If the groove velocity Vg, it is given as 1.25 into 10 to the power 8 meter per second, then the largest dimension will be what? In centimeter. And there is a dielectric that is filled, epsilon r is equal to 3.5. Is it? Okay. Now what is groove velocity actually? So groove velocity, it is equal to V root under 1 minus Fc upon F whole square, isn't it? Where V is equal to C if it is in air filled, and this is equal to C upon root under epsilon r if there is a lossless dielectric in this. So here there is a dielectric, so I will be using another formula. So therefore groove velocity Vg, it is equal to C upon root under epsilon r root under 1 minus Fc upon F whole square, right? Okay. So from here I will get the value of, okay, so Vg, let us calculate few things from here. Vg is how much? 1.25 into 10 to the power 8, right? C is equal to 3 into 10 to the power 8, root under epsilon r is root under 3.5 root under 1 minus Fc upon F whole square, right? So from here I will get the cutoff frequency, right? And from there we can get the we can calculate the value. So this is how much? So from here let us calculate the cutoff frequency Fc upon F. So from here let us calculate the value of Fc upon F. 1.25 to the power 8 multiplied by root under 3.5, right, divided by 3 to the power 8. Zero 0.626, right? Okay. So from here I can get the cutoff frequency value, right? So therefore what is the cutoff frequency? Cutoff frequency will become 0.626 into operating frequency. 0.626 operating frequency is how much? 5 gigahertz. So this is 5 gigahertz, right? So this is how much? So what is the cutoff frequency? 0.626 into 5, 3.13 gigahertz, right? It is a 3.13. Now dominant mode means what? C upon 2a root under epsilon r. This is equal to 3.13 gigahertz, right? So from here a value will be how much? C upon 2 epsilon r into 3.13 giga, correct? So what is the value of a? A will become 3 into 10, they are asking centimeter, yes. So 10 to the power 10 divided by 2 times of root under epsilon r is 3.5, and this is 3.13 giga is 10 to the power 9. So what is the value of a? Let us calculate. Okay, so this is a 2 into root 3.5 into 3.13 to the power 9, 3 to the power 10 divided by answer, 2.56 centimeter. So this is NAT. So answer should be 2.56. So this should be the answer, 2.56. Are you getting the same answer? Question number 13. Clear? Next. Question number 14. At 3 gigahertz, a certain material has epsilon r is equal to 2, mu r is equal to 1, and tan theta is 10 to the power minus 3. The distance travelled by a uniform plane wave before its power gets reduced by 20% is how much meter? So let us see how many of you can do this. So let us see. I am giving you 1 minute time. Let us see how many of you can do it. .7 centimeter. Okay, you are giving the answer for this 4.7. इससे पहले क्या था क्वेश्चन? इसमें भी सेंटीमीटर. किसका आंसर बता रहे हैं आप? 2.56. इसका आंसर बता रहे हैं क्या मिस्टर अविनाश? नो, आशीष. 4.7 सेंटीमीटर नहीं, उसका आंसर 2.56 था. चलो इसमें देखते हैं. देखो, पावर एटेन्यूएशन हो रहा है, राइट? So here you should look at the word power gets attenuated. See here, power, the word is power gets reduces, right, by 20%. So power is involved. The word is here is power. It's not the electric field or magnetic field, it is the power, right? So if it is power, then what? Then what? Power is there, that means the attenuation will be 2 times, right? So if I consider this is the power P and this is Z, let us say this is the P naught. So attenuation will be something like this, right? Attenuation will be something like this. So this is how there will be attenuation, right? This is how there will be attenuation. Now the thing that you have to keep in mind is this is P naught e to the power minus of 2 times of alpha z. Power attenuates at 2 times, right? If it was electric field or magnetic field, it would have been only e to the power minus alpha z. Since the word here is power, so it will be attenuating at double the rate. right. Okay. So it is saying that the distance travelled by the uniform plane wave before its power reduces by 20%, reduces by 20%. So that means reduces by 20%, means 80% is still there. So they are asking what is this z value, right? They are asking what is this z value, so that here you are going to get 0.8 times of P naught. So 20% has reduced, right? So from here 20% has reduced, that means you are left with only 0.8 times of P naught. So they are asking what should be this distance, right? Okay. Now the formula that we are going to use here, it is clearly I have written. So power, I am going to use the formula P naught e to the power minus 2 alpha z, right? So here at z is equal to z, what should be the power? Power should be 0.8 times of P naught, right? So I can say that 0.8 times of P naught is equal to P naught e to the power minus 2 alpha z. So P naught is getting cancelled. So I can say that 0.8 is equal to e to the power minus 2 alpha z, right? So I can say ln 0.8, it is equal to minus of 2 alpha z. So what should be the value of z? Z should be your ln 0.8 upon minus of 2 alpha, is it? Now here, until and unless I can calculate this alpha, we cannot proceed further. Without calculating alpha, we cannot proceed further, right? Because everything is done, only alpha has to be calculated. So how you are going to calculate this alpha? So here tan theta is given, right? So since tan theta, it is given as 10 to the power minus 3, right, which is less than 0.01. So therefore what is the medium? So medium is your good dielectric, isn't it? Medium is your good dielectric. So if it is good dielectric, then the alpha value, it will become sigma by 2 root under mu upon epsilon. So sigma, right? Now we know that sigma upon omega epsilon, it is given as 10 to the power minus 3, right? And root under mu upon epsilon, it is equal to 120 pi mu r is 1 root under epsilon r, right? So what is the value of alpha? Alpha will become, sigma can be written as 10 to the power minus 3 omega epsilon by 2 into 120 pi upon root under epsilon r, correct? So let us put the value 10 to the power minus 3 omega 2 pi into frequency 3 gigahertz. So 3 into 10 to the power 9 omega epsilon 10 to the power minus 9 upon 36 pi, it will be easy to calculate, omega epsilon into epsilon r is 2, right? So this is divided by 2, isn't it, into 120 pi upon root under epsilon r, root under 2, correct? So some terms are getting cancelled, 10 to the power 9 minus 9 gone, right? So this is your 2 pi, so this is 18 or 6, 6, right? So this is 6 pi, so pi 6 6 are 36, right? Okay, 2 3s are 6, okay, so many cancellations, no problem. So let us calculate the value of alpha only directly. So with the help of calculator we have to calculate. In the numerator what we are left with, 10 to the power minus 3, right, divided by 3. 0.044, alpha is coming 0.044 Nepr per meter, right? So we have got the value of alpha. Alpha is known, okay. So once alpha is known, so directly we can find the value of z. So therefore z, it is equal to ln 0.8 alpha minus 2 times of 0.044. So this is ln 0.8 divided by minus 2 into 0.044. 2.53 2.53 meter, right. So this should be the, so they are asking meter or centimeter? Meter. So 2.53 is the correct answer. Are you getting the same? 2.53 is the correct answer. Right. Okay. Next. Question number 15. A lossless transmission line having Z0 as 75 ohm and VSWR as 3, the first voltage minima occurs at a distance of 20 centimeter from the load end. If the operating frequency is 150 megahertz, then the load impedance is what? Question number 15. Fine. So take 1 minute to solve this question. Okay, yeah, 2.54. Okay, correct. So let us solve this question. A lossless transmission line. So what is the characteristic of the line? So line is given as lossless. Line is given as lossless. Characteristic impedance Z0, it is given as 75 ohms. Okay, and VSWRS is given as 3. First voltage minima, right? So first voltage minima. First voltage minima is occurring at 20 centimeter from the load end. If the operating frequency is 150 megahertz, right, they are asking what is the value of load impedance. So ZL is equal to what? Okay. Now, so let us try to draw the figure first. So this is the V minima, right? This is a Z and this is the V maxima, correct. It is saying that characteristic of VSWR is 3. So let us say this is V max is equal to 3. So V minima will become 1. Okay. First voltage minima occurs at 20 centimeter from the load end. Okay. So let us say this is the first voltage minima, right. This distance is given as 20 centimeter, right. So this is the first, first voltage minima. Okay, let us say this is the first voltage minima. So let us say this is the first voltage minima and it is occurring at the load end. Okay. So how you will do it? See, first of all we should know what is gamma. Okay, what is S? What is mod gamma actually? So mod gamma is equal to S minus 1 upon S plus 1. S means 3 minus 1 upon 3 plus 1. So this is 2 by 4. This is equal to 1 by 2, right. Now 2 beta Z minima, first minima, it is the formula is your 2n plus 1 into pi plus of theta gamma, correct. So for first minima n put first minima, n is equal to 0. So, this will become 4 pi by lambda into z minima. This is equal to pi plus theta gamma, right. So, what is the value of theta gamma? So, theta gamma, it will become 4 pi by lambda into z minima minus pi. Okay. Minima is 20 centimeter, lambda. So, how you will find lambda? Now, we know that nothing is mentioned. So, lossless line. So, we know that we can use C equal to f lambda, right. So, from here I will get the value of lambda as C by f. Why I am using C by f C equal to f lambda? First of all, it is lossless. So, for each line in the transmission line, LC, product of LC is always equal to mu epsilon, that you know, right. For each line of the transmission line, L into C product is always equal to mu into epsilon. So, voltage, so velocity V, which is equal to 1 by root under LC, that means how I have written, I will just give you the concept. We know that velocity for each line in transmission line, for each line, we have LC product is always equal to mu epsilon, right. So, velocity is equal to 1 upon root under LC. This is same as 1 upon root under mu epsilon. This is nothing but your C upon root under epsilon r, isn't it? So, here they have not mentioned anything about root epsilon r. So, I will take it to be 1. So, V will become C, right. So, this will become C at epsilon r is equal to 1, isn't it? So, nothing has been mentioned about the permittivity or permeability. I will be taking epsilon r to be 1. Okay. So, velocity is equal to C. So, therefore, I can directly we know the formula V equal to f lambda. So, instead of V equal to f lambda, I have used the formula C equal to f lambda, right. Now, it is clear, right. So, C equal to f lambda. So, lambda is equal to C by f. So, this is equal to 3 into 10 to the power 8. So, let us take in centimeter, because this is lambda z is given in centimeter. So, 10 to the power 10 upon frequency of operation 150 mega. So, this is 150 mega means 10 to the power 6. So, let us calculate this value. So, 3 to the power 10 divided by 150 divided by 6, 200, right. So, 200 centimeter, correct. So, this is a 200 centimeter. So, just substitute this value. So, this is a 4 pi upon lambda is 200 and z minima is at 220 minus pi, right. So, 20 this is your 10, right. So, this is how much? This is your 0.4 pi, 0.4 pi minus pi, right. So, this is a minus of 0.6 pi, right. So, minus so this is same as minus 108 degree, isn't it? So, pi means 180 degree, 180 into 18 into 6 is 108, right. So, point, so zeros and point will get adjusted. So, I am going to get minus 108 degree, okay. So, here you can see that theta gamma is what? So, you are getting theta gamma. So, what is the value of gamma? So, gamma, which is equal to mod gamma at an angle theta gamma, right. So, this is a 0.5 at an angle minus of 108 degree. It means that what is the nature of the load? It should be r minus jx, nature of the load, because theta gamma is coming to be negative. It means that if I extrapolate this graph, so it is going to hit it somewhere here, right. So, that means if I produce this one, right, if I produce this graph, so it is going to cut somewhere here, isn't it? It is going to cut somewhere here. So, obviously here. So, this is the graph of load r minus jx, okay. So, even though they are not asking what is the nature of the load, there may be the question that may arise that whether, tell me the nature of the load, whether it is purely resistive, purely inductive, purely capacitive, or resistance plus inductance, resistance plus capacitance. So, from the graph it is quite apparent that it is your resistance and capacitance connected together, right. So, r minus jx, okay, fine, but they are not asking the nature, they are asking what is the value of the load impedance, right, in ohms. That means we have to take the mod of this value, then only we will get the value, okay. So, ZL, fine. So, everything is done. So, now what do you have to do, right. So now what I will do? So now we know that gamma, it is equal to ZL minus Z0 upon ZL plus Z0, right. So from here I will get the value of ZL as Z0 1 plus gamma upon 1 minus gamma, right. So Z0 is how much given in the question? 75. So Z0 is your 75, 1 plus gamma. 1 plus gamma means 1 plus 0.5 at an angle of minus 108 degree divided by 1 minus 0.5 at an angle 108 degree. So from here directly you will get the magnitude, right. From here directly you will get the value of magnitude, correct. Okay. So I have the calculator, so it will be easy for me to calculate. So this is 1 plus 0.5 at an angle minus of 108 degree divided by 1 minus 0.5 at an angle minus 108 degree. So it is coming as 75 multiplied by 0.777 or 0.777 at an angle minus 51.74. Are you getting the same value? Just check the calculation, right. So what is the value of mod ZL? ZL, so 75 into 0.777, 58.275 at an angle minus of 51.74 degree, right. So they are asking mod of ZL. So mod of ZL will be how much? 58.275. So this should be the answer. Right. Clear. So this is the answer. So what is they are asking resistance or what? Let us say if the operating frequency, then the load impedance. They are asking what is the value of load. They are not asking what is the value of resistance or reactance value. They are asking the load. So load I can easily find, right. Rx can be found from this value, right. So cos will become resistance, sin will become reactance. So if they have individually, if they have asked what is the value of resistance or what is the value of the capacitance, we can easily calculate it, right. So this cos will give you the resistance, sin will give you the reactance part, right. So answer should be 58.275 ohms. Is it clear? Yes, Ashish, you are correct. It is resistance and capacitance. Fine. Okay. Next question. Question number 16. The directive gain of a certain lossless antenna is 20 dB. Okay. The capture area of the antenna required to produce this gain when operating at 10 gigahertz frequency is how much? So they are asking basically the capture area is, what is the capture area? This capture area is nothing but the effective area only. Capture area is nothing but your effective area, right. So they are asking what is the effective area. Okay. See, directive gain is given as GD is given as 20 dB. This is equal to 100, right. This is equal to 100. Capture area of the antenna required to produce this gain operating at, so operation of frequency is 10 gigahertz. They are asking what is the effective area. So simple question, right. We know that effective area is how much? Effective area is nothing but your lambda square upon 4 pi into GD. Lambda is nothing but your C upon F whole square upon 4 pi into GD. C by F 3 into 10 to the power 8 upon frequency 10 giga 10 into 10 to the power 9 whole square upon 4 pi into 100. Right. So 3 to the power 8 divided by 10 to the power 9 whole square divided by 4 pi into 100. 1 2, this is in 10 to the power minus 3, 1 2 3, 7.16 meter square. This should be the answer. Right. So, answer is 7.16. Right. So, this is the answer 7.16. Question number 17. Two lossless dielectric materials have a boundary defined by the zx plane if the electromagnetic wave is incident from one side to other and Brewster angle is 30 degree for the media. The corresponding critical angle for the pair of media is how much degree? Right. So, I will give you 1 minute to solve this question. Try this question. Okay. See, let us solve this. XZ plane, right? XZ plane. Let us say this is your x axis and let us say this is the z axis. Correct. So, let us say this is the x and let us say this is the z. So, let us say this is the interface. Correct. Arbitrarily, I am calling this to be medium 1 and I am calling this to be medium 2, right, arbitrary. Two lossless dielectric material have a boundary defined by xz plane, right. So, this is xz plane means this is your y axis, right, defined by the xz plane. If the electromagnetic wave is incident from one side to the another at Brewster angle 30 degree. So, let us say it is falling at Brewster angle 30 degree, correct. So, let us consider this is the Brewster angle theta b, this is at 30 degree, correct. For the corresponding critical angle for the pair. So, what is critical angle? Critical angle means, so they are asking what should be that corresponding critical angle, right. So, what should be the critical angle? If I consider this the refractive index as n1 and this is n2. So, for critical angle this theta this should be at 90 degree, right. So, the angle of incidence, right, so will be how much. So, they are asking what will be the corresponding critical angle, so that there is a value will be theta c, right. So, at critical angle we know that it will gauge the interface, correct. So, 7.16. Oh, you are telling the previous answer, okay, fine. Now, we know that Brewster angle tan theta b, it is equal to root under epsilon 2, okay. Refractive index, this n is your refractive index, let us say this is epsilon 1 and let us say this is epsilon 2, right. What is n here? N I am calling to be the refractive index, okay, and I am calling it to be refractive index. So, tan theta b, it is equal to epsilon 2 upon epsilon 1, right. Epsilon 2, can I write it like this, epsilon 2 upon root under epsilon 1, and we know that this is nothing but a refractive index n2 upon n1, right. Because we know that the refractive index n is equal to root under epsilon r, isn't it? Okay. So what is the value of n2 upon n1 then? n2 upon n1 is equal to tan of 30 degree. Tan 30 is how much? 1 by root 3, right? So we have got this value. Further, from Snell's law, because critical angle will come from the Snell's law. So from Snell's law, right, n1 into sine of theta 1, it is equal to n2 into sine of theta 2, is it? Okay. So n1 into sine of critical angle theta c, it is equal to n2 into sine of 90 degree, because at critical angle the refracted ray will be at 90 degree, right. So therefore what is the value of sine of theta c? Sine of theta c, it will become n2 upon n1, or you can say that 1 upon n1 upon n2, isn't it? So this is how much? Okay, we have given n2 upon n1, right? So why I am doing like this? So n2 upon n1 is nothing but a 1 by root 3. So therefore what is the value of critical angle theta c? So it will become sine inverse 1 by root 3, right. So what is the critical angle? Sine inverse 1 by root 3. So sine inverse 1 divided by root 3, 35.26 degree, 35.26 degree. This should be the answer. Yes, correct, Ashish. So this is the answer to this question. Question number 18. A non-uniform good conductor supports a uniform plane wave traveling with a velocity of 1.8 into 10 to the power 6 meter per second. If the wavelength is 0.28 millimeter, then the conductivity of this non-magnetic medium is how much? So here clearly they have said that it is a non-magnetic. So non-magnetic means mu r should be equal to 1, isn't it? Non-magnetic means mu r should be equal to 1, right. Now how to solve this? Okay, so what they are asking? Conductivity. Okay, fine. Velocity is given, right? So velocity is given as 1.8 into 10 to the power 6 meter per second, and lambda value it is given as 0.28 mm. Okay, they are asking what should be the conductivity of the conductor. Okay, non-magnetic. Okay, fine. So can I get the frequency? Okay, so we know that V equal to F lambda, right. So from here I will get the frequency as V upon lambda. 1.8 into 10 to the power 6 divided by lambda is 0.28 millimeter, means 10 to the power minus 3. So 1.8 to the power 6 divided by 0.28 to the power minus 3. 6.43 gigahertz. 6.43 gigahertz, that is the frequency. Okay. Now we know that V equal to omega upon beta. This is equal to omega by alpha, because since for conductor alpha beta will be same, right. Okay. So V is equal to omega. Okay, we can calculate it. We have calculated alpha. It is equal to root under pi f mu into sigma. Conductivity they are asking. Okay, so from here, pi f mu sigma root under, this is equal to omega upon v, right. So therefore root of sigma, it is equal to omega into v root under pi f mu, right. Omega means 2 pi f upon v root under pi f mu. So this is equal to 2 pi root f upon, or you can say that we can 2 times root of pi f upon v root of mu. So let us put the value 2 into pi, frequency of operation we have got 6.43 giga 10 to the power 9 divided by velocity of is 1.8 into 10 to the power 6 into root under 4 pi into 10 to the power minus 7, right. So therefore what is the value of sigma? So from here I can directly calculate the value of sigma. So this is your root under 4 pi into 10 to the power minus 7 into 1.8 to the power 6, right. So 2 into root under pi into 6.43 to the power 9 divided by 1.41 into this is a root, so whole square 1.98 into 10 to the power 4 mho per meter. This should be the answer. Let us check which option is correct. 1.98 into 10 to the power 4, yes, option A is correct, option A. Correct. Next, question number 19. A metallic hollow waveguide has a cutoff frequency of 2 gigahertz for its dominant mode of operation. If the guide dimensions for its cross section are in the ratio 1:2, the first degenerate modes of T and Tm possibly at m equal to 1 and n equal to 1 have the cutoff frequency will be how much? Okay. Yes, A is the correct answer. So let us solve this. See, a metallic hollow waveguide is given, right. Cutoff frequency of 2 gigahertz. So cutoff frequency 2 gigahertz at dominant mode, right. Now what will be the dominant mode? So that is given in the second line. If the guide dimension is in ratio, that means A by A is to B, it is your 1:2, right. That means, or you can write it like this also, A by B, it is 1/2. It means that A is less than B and A is B by 2, isn't it? A by B ratio is 1/2, that means B is larger, right. So A is smaller, so A is less than B and A is also B by 2, right. So that means dominant mode in this case it will become T01, right. So from where we have got this concept? So from here, right. So from here T01 mode, correct. Okay. Then they are asking what will be the first degenerate mode cutoff frequency, m equal to 1, n equal to 1. Okay. So to find the cutoff frequency for the degenerate mode, that is m equal 1 and n equal to 1, first of all we have to find A and B, right. Okay. So, for T01 mode, for TE01 mode, right. So, what will be the cutoff frequency? It will become C upon 2B. Any medium is any dielectric is given? No. So, C upon 2B, right. So, therefore, C upon 2B, it should be equal to 2 gigahertz, 2 into 10 to the power 9. So, what is the value of B? B is equal to C upon 4 into 10 to the power 9, right. So, let us directly calculate in the centimeter. So, 3 into 10 to the power 10 centimeter divided by 4 into 10 to the power 9. So, what is the value? 3 to the power 10 divided by 4 to the power 9, 7.5. So, this is coming to be 7.5 centimeter B value, right. Okay. So, what will be the value of A? What will be the value of A? Now, since A is equal to B by 2, right. So, this is a 7.5 divided by 2 centimeter, right. So, divided by 2, 3.75 centimeter, correct. So, we have got A and B both. Now, so therefore, now they are asking the cutoff frequency. So, therefore, cutoff frequency for T11 mode, either T11 or TM11, because both are degenerate mode, or TM11, this will become C upon 2 root under 1 by A whole square plus 1 by B whole square, isn't it? Fine. So, cutoff frequency, it will become 3 into 10 to the power 10, right, because you have taken in centimeter. So, there divided by 2 root under 1 by A, 1 by A is your 3.75 whole square plus 1 by 7.5 whole square. So, let us calculate the cutoff frequency here. So, this is 1 divided by 3.75 square plus 1 divided by 7.5 square, (4.47 gigahertz). 4.47 gigahertz. This should be the answer. So, this is NAT. So, answer should be 4.47, is it? Question number 20. An air dielectric boundary has the following fields to consider in air. Okay. In air, electric field normal is 5 volt per meter, E tangential is 15 volt per meter. If the dielectric has epsilon r is equal to 10, then mod E in the dielectric has a value of how much, right? Question number 20. So, let us say this is the boundary, even though they have not mentioned which interface. So, let us say this is any interface. Let us say this is the normal. What it is given? Air dielectric. Okay. Let us say this is medium 1 and let us say this is air, not mentioned. I can take any one. Medium 2 and let us say this is the dielectric. In the dielectric, epsilon R2 value is given as 10 and here epsilon R1 value I have taken arbitrary, medium 1 below, medium 2 up. You could have taken in the other way also, right? Okay. In air, dielectric boundary condition has the following fields: electric field normal in air. Okay. So, let us say this is the electric field going and let us say this is electric field coming, correct. Let us say this is the E1 vector. Okay. So, it will have obviously two components, one component in this direction, another component in this direction, right. This angle, let us say this is theta 1. So, what it is said that electric field normal. So, this is E1 n vector, this is given as 5 volt per meter, and tangential, that is E1 t vector, right, magnitude it is given E1 t, it is your 15 volt per meter. Now, what they are asking? Then mod of E in the dielectric. So, that means they are asking what is the value of mod of E2. This is the question. I hope the question is clear to everyone. So, they are asking what is the value of mod of E2. Is it? Okay. Now, fine. So, question is clear to everyone. Now, we know that from boundary condition, if I apply boundary conditions, the first boundary condition says that E2 tangential should be equal to E1 tangential, right. So, this implies the second medium electric field E2 tangential will be same as E1 t, that is 15 volt per meter. Second boundary condition, now nothing is mentioned about the surface charge density. So, I will consider rho s to be 0 coulomb per meter square, right. So, at rho s equal to 0, we know that d2 n vector is equal to d1 n vector, that is the second boundary condition, right. Okay. So, this can be written as epsilon 2 into E2 n vector is equal to epsilon 1 into E1 n vector. So, what is your E2 n vector? It is equal to epsilon 1 upon epsilon 2 into E1 n vector. Epsilon 1 upon epsilon 2, 1 upon 10, that is 0.1 into E1 n into 5, 0.5 volt per meter. This is your E2 n. So, therefore, what is your E2 vector, sorry, mod of E2? So, mod of E2 will be how much? It is your root under 15 square plus 0.5 square, is it? (15 square plus 0.5 square root 15). It is coming to be 15.008, right. It is coming 15.008 volt per meter. So, this should be the answer. Now, this is NAT. So, answer will be 15.008. Yes, Ashish Kumar, correct. Right. Next. This is MSQ, multiple select question. For the network shown in the figure, correct statements is or are. So, there is an inductor JX 50 ohm and characteristic impedance 50 ohm. They are asking S11 parameter will be how much, S12 will be how much, network is symmetrical, the network is lossless. So, which of the options are correct? And this is MSQ, that is multiple select question, one or more than one can be answer can be correct. Okay. So, let us solve it. Right. So, this is a network that has been given. So, we have to find S11, S12, whether network is symmetric. Obviously, network is clearly it is symmetrical, right. So, network is clearly it is symmetrical. You either see from this side or that side, it is clearly symmetrical. So, there is no issue. So, C will be the correct answer, right. So, from the diagram only we can make it out that the network is symmetric, correct. So, C is correct. Apart from C, we have to check A, B and D. Okay. So, one by one we will do, right. So, first of all, let us check the A option. They are asking S11, right. How to find this S11? This is inductor of 50 ohms. See, this is an inductor 50 ohm, right. So, you have to connect Z0 which is equal to 50 ohm, and this is your Jx which is equal to J50. right, and this is the box. So what is your Z1? Z1, it is equal to input impedance 50 plus J50 ohms, right, Z1. What is the formula of S11? S11, it is equal to Z1 minus Z0 upon Z1 plus Z0, is it? Z1 is how much? 50 plus J50 minus 50 divided by 50 plus J50 plus 50. So 50 is gone. So this is equal to J50 upon 100 plus J50, is it? So what is the value of S11? So this is equal to you can say that this is a J1 upon 2 plus J1. So this is 1 at an angle 90 degree and this is a root 5 at an angle, so tan inverse half, right. So tan inverse 0.5, 26.56 degree, 26.56 degree, right. So what is the value of S11? So therefore S11, it is your 1 divided by root 5, 0.447 at an angle, so 90 minus 26.56, 63.44 degree, right. Oh. So this should be the answer, 0.447, 63.44, 0.447, 63.44, option A is correct. Option A is also correct. Okay. Next, option B. Coming to option B. Now you can see that option B, they are asking S12 or S21. What is they are asking? S12. Okay. S12. Now we can see that since network is symmetric, network is symmetry. What does that mean? Network is symmetry, it means that S12 will be same as S21. So that means if I can calculate S21, I will calculate get the value of S12 also, right. Now here what is the network given? This is your inductor and this is the resistor, right. This is your Jx which is equal to J50 and this is a Z0 which is equal to 50, right, and it is basically put in a matrix form, right. Now here we have got Z1, right, which was your 50 plus J50, is it? Okay. Let us say the current going in this is your I1 and current through this is your I2, correct. So what is the formula of S21? Output voltage, that means I2 into Z0 divided by input voltage I1 into Z1 into 1 plus S11, right. So here I1 and I2 both are same because there is no other element, there is no current division, it is in series, so current will be same. So I1 I2 will be same, so this is nothing but your Z0 upon Z1 into 1 plus S11, right. So what is the value of S21? Z0 is how much? 50 upon Z1 is how much? J50, no sorry, not J50, Z1 means 50 plus J50 into 1 plus S11 is 0.447 at an angle 63.44 degree, right. So from here I will get the value of S21. So S21, it is equal to 1 upon this is 1 plus J. So 1 plus J means how much? Root 2 at an angle 45 degree, right, and this is 1 plus 0.447 at an angle 63.44 degree, right. So let us calculate this value. This is 1 plus 0.447 at an angle 63.44, 1.265 approximately at an angle 18.43 degree, 18.43 degree approximately divided by root 2 at an angle 45 degree, right. So, this is 1.265 divided by root 2, 0.895 approximately at an angle 18.43 minus 45 minus 26.57, right. So, this is S21 and S21 and S12 is same. So, S12 value it will become 0.895 at an angle minus of 26.57 degree. So, this should be the answer. Let us check S12 0.895, 0.89, okay, no problem, and this is angle is minus 26, it is plus 26. Option B is wrong. A is correct, B is wrong, C is correct, right. Fine. Option D, network is lossless, right. Option D. We know that for lossless, mod of S11 whole square plus mod of S21 whole square should be equal to 1. So, S11 mod is how much? S11 0.447, 0.447 whole square plus 0.895 whole square. Let us see how much it is coming. 0.447 whole square plus 0.895 whole square. It is coming 1. So, it is lossless. So, D is also correct. So, lossless it is D. Lossless it is, yes, it is lossless as well. So, D is also correct. So, answer should be A, C and D, right. Answer is A, C and D. Yes. Okay. Clear everyone? Now, coming to the last question of the session, right. Last question of the session. A lossless antenna operates at a frequency of 3 gigahertz, has a maximum effective aperture of 0.2 meter square. Assuming antenna is perfectly matched and radiates in free space, correct statements is or are. This is MSQ. So, one or more than one can be answer, correct, should be correct. Directivity of antenna is approximately 140, okay. If the operating frequency is doubled, keeping the same physical antenna, the directivity increases by 6 dB. For the same antenna, if wavelength is half, the effective aperture reduces by a factor of 4. The maximum power density at a distance r in the direction of maximum radiation is proportional to effective area. So, I am giving you 1 minute, just tell me what is the correct answer. A, B and D. Okay, let us see. One by one we will check. Question number 2. So, this is the last question of today's session. A lossless antenna, right, operating frequency f is given as 3 gigahertz. Okay, what else? Maximum effective aperture, that is AE max, 0.2 meter square. Antenna is perfectly matched, radiates in free space. Okay, fine. Directivity of the antenna. So, first part they are asking the directivity. Now, we know that effective area, it is equal to lambda square upon 4 pi into GD, right. Okay. So, what is the effective area max? Effective area max, it will become lambda square upon 4 pi into GD max. What is GD max? This is nothing but your directivity. So, lambda square upon 4 pi into directivity, right. So, what will be the happen to the directivity value? So, D will become 4 pi into effective area upon lambda square, 4 pi. Now, since radiation is happening in the free space, so C upon F whole square, right. So this is a 4 pi, effective area is 0.2 and C upon F 3 into 10 to the power 8 divided by frequency of operation is 3 gigahertz, 3 into 10 to the power 9 whole square. So let us calculate this value. This is your 3 to the power 8 divided by 3 to the power 9 whole square. So this is 0.8 pi, right. So 0.8 pi divided by answer 251.32. Let us say approximately 251. How much it is? 140. Option is absolutely wrong. So it should be 251, but here it is given 140 wrong. Next. B part. So A part, so A is wrong. B part. B part, if the operating frequency is doubled, okay, operating frequency is doubled. So frequency is now doubled means 6 gigahertz. Okay. Keeping the same physical antenna, the directivity increases. Okay, so directivity formula, right. So what is the directivity here? So it will become 4 pi effective area upon, or directly we can see that here directivity is area is same, so D is inversely proportional to lambda square, right. You can see that D is inversely proportional to lambda square, right. So as D is inversely proportional to lambda square, correct. So D dash upon D, it is equal to lambda square upon lambda dash square. So D dash, it is equal to lambda upon lambda dash whole square into D. Now this can be written as lambda is inversely proportional to frequency, so F dash upon F whole square into D. Why? Because we know that F is inversely proportional to lambda. So what is the new directivity D dash? So new frequency is 6, old frequency was 3 whole square, and to old directivity was 251, right. So this is 6 by 3 is 2, 2 2s are 4. So 251 into 4, 1004, right. So the new directivity I am going to get is how much? 1004. Now they are asking if the operating frequency is doubled, then they are asking in dB. Okay. So here, right. So therefore D in dB will be how much? D in dB, it is your 10 log 10 251. So D is inverse proportional to lambda square, you can check from here because the physical area they have kept the same. Okay, so this is how much? And D dash dB, it is equal to 10 log 10 1004. So let us find this first. This is coming to be 30 dB. Okay. So log 251 into 10, 23 point, that is approximately 24 dB, right. So what is the increment? Increment of plus 6 dB, right. So that means if, so what was the question? If the operating frequency is doubled, so I have doubled the frequency keeping the same physical antenna, that means antenna has not been changed, the directivity increases by 6 dB, yes, plus 6 dB, it is correct. So option B is absolutely correct. Option B is correct. So A is wrong, B is correct. Next, C option. Option C. For the same antenna, if the wavelength is halved, the effective aperture reduces by a factor of 4. So effective area, right. Now we know that for the same antenna, if antenna is same, right. Now here, if antenna is same, it means that its effective area will be also same. How it will change? If the antenna is a physical, right, physical object, So if the antenna, suppose this is the antenna, if it is the same, its effective area will also remain the same, or so that means it is not going to change. So for the same antenna, if antenna is the same, if the wavelength is halved or whatever you can do, the effective area will not change, right? Or so it is wrong, because antenna is the same, how the effective area will change. Otherwise, mathematically also you can prove that. What is the formula of effective area? See, yeah, or alternate effective area formula is what? Lambda square upon 4 pi into directivity, right? And since directivity itself is inversely proportional to lambda square, directivity is inversely proportional to lambda square, so what will happen to the effective area, right? So effective area, it is constant, isn't it? So effective area, it is equal to lambda square upon 4 pi, okay, directivity, and directivity is itself is inversely proportional to lambda square. So if d is, if I replace by 1 by lambda square, so I am getting constant, effective area will not change. If the physical antenna is clear, is there, so effective areas will be also remain the same, so effective area will not change. So option C is wrong, option C is wrong. Option D, the maximum power density at a distance r in the direction of maximum radiation is proportional to effective area. Let us check for option D. Option D, power density P average, this is given by the formula P radiation upon 4 pi r square into GD, right? So this is the formula, this is the average power density at a distance r, right? Now this can be written as P radiation upon 4 pi r square, directive gain is nothing but your lambda square upon 4 pi into effective area. It means that average power density P average is directly proportional to effective area, right? So average power is directly proportional to effective area. So the maximum power density at a distance r is in the direction of maximum radiation is proportional to effective area. Yes, that is also correct. So what is the answer? Answer is B and D, right? So C is wrong, C is wrong, B is correct, and D is correct. So answer is B and D, right? So I hope things are clear to everyone, right? So with this we finish our today's session, right? So I hope you have applied the concept generously. आपने जो भी अब सीखा था EMT के अंदर वो आप लगा पाए, किसी में मैंने थोड़ा सा समय भी दिया था ताकि आप उसको रिकॉल कर सको, राइट? सो एट द एंड ऑफ द डे प्रैक्टिस मेक्स एवरीथिंग परफेक्ट. तो यू हैव टू प्रैक्टिस, यू हैव टू रिकॉल, रिकॉलिंग आपका फास्ट होना चाहिए, तभी हो सकता है जब फॉर्मूलाज आप वेल एक्वेंटेड हो, राइट? सो ऑल द बेस्ट फॉर योर कमिंग एग्जामिनेशन फॉर गेट एंड इंजीनियरिंग सर्विसेज, राइट, एंड फॉर और एनी अदर एग्जामिनेशन दैट यू आर गोइंग टू राइट. सो ऑल द बेस्ट फ्रॉम माई साइड. I hope you come with a very bright, colorful result. So thank you everyone.